Well, good morning to you. If you're in the continental U.S., it's a morning, but welcome anyone that's present. My name is Steve Ferguson, and we're pleased to welcome you to the Washington Labs Academy webinar series. We hope you'll find the next hour or so useful and informative. We've developed a webinar series to deal with some of the administrative and technical issues that our customers face on a day-to-day basis. We recognize that engineering challenges can be complex, and we're always looking for ways to improve the technology industry. Before we begin our presentation, I want to go over a few housekeeping details. First, I hope everyone can see the title slide on the screen, inviting you to the Immunity Requirements webinar today. The attendee sound is muted to keep the meeting quality as high as possible, and a recording of this event is underway and will be distributed to all that registered for the event after we're able to process the recording. Along with the presentation, a copy of the presentation will be included with the link to the recording. Remember, the recording link is valid for 30 days. A training certificate will be sent to the live attendees. For your convenience, full screen view might be preferred. All you have to do is select View Full Screen, and to get away from that, an escape key will let you merge through that. We encourage questions. Send the questions via the chat or the Q&A icon as you find convenient for you. We really prefer sending those to the host rather than interrupt the speaker. So send those to the host or the question and answer, and we will feed those questions to the presenter at the end of the event. We'd like to hear from you. You can contact us via Washington Laboratories Academy at WLL or that phone number, 301-216-1500. And you're always welcome to contact our speaker directly, Steve K. at WLL.com. So let me introduce the speaker, Stephen Koster, President, Washington Laboratories Limited. Steve has over 30 years of experience in testing systems and devices for regulatory compliance. His expertise spans a full range of product evaluations from information technology, medical, machinery, measuring, and communications, including wireless devices. He heads the Washington Laboratory team, accomplishing all manner of product compliance and evaluation. Mr. Koster is active with the IEEE EMC Society and frequently presents at EMC Symposium on Emission Measurements. He's on the TCB Council Board of Directors and on the ACIL-CAS Executive Committee. I'm also aware that he is part of a tutorial team for this year's symposium in Washington, presenting a wireless subject matter. Welcome, Steve. Let me arrange to get your slides on here and give you control.
Awesome. Thank you, Steve. Good morning, everyone. Welcome to this presentation on immunity. This is going to take into account some of the latest in the requirements, being the RED goes into effect in just under 3 weeks. Basically, what we're going to do is we're going to look at the immunity requirements as specified in the 301-489 series. It looked like a lot of the people on this webinar are all familiar with testing and test facilities, etc. So we'll be able to touch base on these. So first off, what standards do you use? Okay, standard, if you want to use the harmonized standard for the radio equipment directive, well, you have to go to the journal, the official journal, and see what's there. Unfortunately, at this time, none of the 301-489 series standards are on the harmonized standards through the OJ. That causes some issues, but it's not terrible because we can get around that. This is when I go to the official journal page, this is what I see. And as you can see, it gives you the directive number 2014/53/EU. It does give you a link directly to the directive, so you can read all the legalese if you so would like. And it does have applicability as of 13 June 2016. So it was voted in last year. But what happens is the RTTE directive, the 1999/5/EC, can no longer be used to show compliance after June 13, 2017. So there's only a few more weeks left where the RTTE is still applicable, and then it's all the radio equipment directive. You can also, from this page, you can click on that guidance on the CE mark for professionals, and that'll take you to the red guide that helps you understand how the standards or how the directive should be interpreted. The official journal, the top of the page will look like this. It'll tell you the reference and title of the standard. What standard is it that's been printed? When did we first publish it in the official journal? Any reference of a superseded standard, the old revisions, etc., and the date that the cessation of, presumption of, conformity of the superseded standard will be listed, and that's your transition date when the old standard can no longer be used. And what article does it cover for the directive? Is it 3.1.A, 3.1.B, 3.2, 3.3, etc.? There we go. So we use primarily the 301.489 series, and the latest 301.489-1 is a 2.1.1 series standard that was published in November of 2016. It's common technical requirements for all of the 301.489 standards. They all bounce back to this document. The document part 1 again is the common requirements, but it has several parts. I think I counted up to like 54. So part 2 is specific requirements for radio paging equipment. Part 3 is specific for short-range devices, and that's from 9 kilohertz to 40 gigahertz. Part 4, as you see, is all the different 489 parts have specific radio types in mind. We use a lot of the -3, we use a lot of the -17 for Wi-Fi, things like that. But as you can see from the present slide, you know, if you're private land mobile or GSM or radio link cordless audio and the ear monitoring device, all of these parts are specific to that type of radio. So what are the test conditions? Well, the equipment needs to be tested in a normal test condition according to the relevant product and basic standard, or to the information accompanying the equipment, which are within the manufacturer's declared range of humidity, temperature, supply voltage, and the test conditions have to be recorded in the test report. So basically, you have to be able to function that device. That device has to be able to function normally, has to be able to you have to be able to test it in that type of configuration. You have to have test signals, but adequate measures should be taken to avoid the effect of immunity test signals on both the measured equipment and the signal sources for the wanted signal located outside of the test environment. So, you know, if you're doing emissions work or and you can't fault somebody for one of the test signals that you're using, or if for some reason your immunity, when you're running the immunity, it affects the actual test signal, then the radio is not going to operate properly. A transmitter has to be modulated with the normal test modulation by an internal external signal source capable of delivering the normal test modulation. So you have to, again, you have to have it tested in its normal mode, normal operation, because that's how that's what you wanted to evaluate it in. You don't want to evaluate a device different than how it's going to be used on the market. Big thing with the RF exclusion bands. The exclusion bands should be derived using the methodologies. They have different methodologies in different sections of the document that show how much of an exclusion band your device will have. It's going to be dependent on your frequency band or the actual frequency of transmit. But whenever you do use an exclusion band, the specific frequencies excluded from the assessment have to be detailed in the technical documentation. So you really have to think about what you're doing, especially if you're doing emissions, for example, for the 489, you're really looking at the case radiated or more of the digital performance of the device from an EMC standpoint. And the transmitter pulse is not a part of that evaluation. That gets taken care of in the 3.2, the efficient use of spectrum, and typically another standard. So you would exclude that frequency range from your assessment in this particular instance because it's not part of the digital. And the other thing is they have two different ways to also look at the receiver exclusion bands. I don't know about everybody out there, but I believe a receiver is supposed to receive. So if I'm rolling through it with a radiated immunity signal, I would suspect that the device would receive that. So there is two different ways to determine how much of a receiver exclusion band you have for these different tests. And again, anytime you use the exclusion bands, you really need to document exactly what frequencies were excluded in your test results. And then when you're testing, doing all the immunity tests, a very real important thing is performance criteria. The performance criteria is basically determining how the unit has to operate during these tests. Now we have performance criteria for continuous phenomena, and we have performance criteria for transient phenomena. If you think about the continuous phenomena, that's devices that are going to be permanently in the area. For example, if you're just down the street from an AM or FM transmitter or a television station, those signals will be permanently at your facility. Whereas a transient phenomenon is more of a the surges that you get from lightning strikes or the inductive coupling you get from when motors start on the same bus, things along that lines. And they have different performance criteria depending upon whether it is continuous or a transient. And they have it for both the transmitters and the receivers, as one would suspect. So the performance criteria for continuous phenomena is basically in the -1, the 489-1. It reads that if no further details are given in the relevant 301-489 series, so if there's not something special to your radio type, then the following general performance criteria is for the continuous phenomena. So, and you may find that the different series, and we'll look at the -3, for example, a little later, and they may have a different performance criteria, so you have to really pay attention to the specific radio type. But in general, during and after the test, the apparatus has to continue as operate as intended. No degradation of performance or loss of function is allowed below a permissible performance level specified by the manufacturer when the apparatus is used as intended. In some cases, this performance level may be replaced by a permissible loss of performance, which is, nice to say, but you really don't want to sell a product that's not going to work when it's sitting next to a FM radio station, for example, because you don't know what people will be there. So continuing on, during the test, the UT shall not unintentionally transmit or change its actual operating state and stored data. Okay, you can't. So the minimum performance level of the permissible performance is not specified. If the minimal performance level is not specified by the manufacturers, these can be deduced from the product description and documentation and what the user may reasonably expect if used as intended. That's a big piece of that performance criteria. What can the user expect? Can you tell the user that, oh, by the way, you're just too close to this particular transmitter, so you can't use that? A lot of people won't go for that. Now, if you have transient phenomenon, again, it has the same note. It's like if no further details are given in the higher series, then you use this generic one, which states, after the test, the apparatus shall continue to operate as intended. No degradation of performance or loss of function is allowed below permissible performance level specified by the manufacturer when the apparatus is used as intended. Now notice it said after the test. There's no indication that it has to perform as intended during the test for a transient phenomenon. In some cases, the permissible performance level may be replaced by a permissible loss of performance. But during the EMC exposure, a degradation of performance is, however, allowed, as long as you have no change of actual mode of operation. For example, no unintended transmission, you can't turn the unit from on to off, and you do not lose stored data. If the minimum performance level, again, is not specified, then we can figure it out and decide what's reasonable. But those two are very important to know. You can't change the operating mode, and you cannot lose stored data. But aside from that, as long as the unit's self-recovering after the test, you can qualify or you can comply to that performance criterion. For the purpose of EMC performance assessment, they have equipment classifications. Radio equipment, associated ancillary equipment is going to be tested different depending upon what it is. You have fixed use, you have vehicle use, and you have portable use. Some of the definitions that they have, base station or fixed equipment is radio or ancillary equipment intended to be for operation at a fixed location and powered directly or indirectly by the AC mains or an extended DC mains network. So they expect that these devices will be plugged into the AC mains, so you'll see that when they have the requirements will be they will be required to test at the AC mains, whereas some of the other equipment may not. Mobile equipment is a receiver, transmitter, or transceiver intended for installation and use in a vehicle and powered by the main battery of the vehicle. So that's going to be a vehicular type of situation, and they call out the requirements separate for that as opposed to a fixed. And then you have the portable equipment. It's a radio or ancillary equipment intended for portable, maybe handheld operation with its own battery. It's not necessarily connected to the AC mains. So here it's a little tough to see, but the applicability overview table out of 301-489-1, it'll tell you that the radio, which one? There it is. The radio or ancillary for fixed use, for vehicular use, and for portable use. Radio RF magnetic field, and you'll see it's 80 megahertz to 6 gigahertz now, is applicable to all types of radios. ESD is applicable to a fixed, but it doesn't appear to be applicable to a vehicle. It is applicable to a handheld. If you're doing fast transients, again, it's applicable to fixed unit, not applicable to your vehicle or your portable device. So it kind of depends on the type of radio that you have to determine what you're doing as applicability for the tests required. And then they have clauses later in the standard to show exactly what you need to do for those particular tests. And this is, excuse me, the rest of that table. And you'll see that surges line to line, for example, are not applicable for vehicle or equipment use. And dips and interrupts, of course, you're not going to do them if you don't have the AC power. Take a quick look at one of the higher level standards, and you'll see that they're a lot less voluminous. The -3 has probably one quarter to 1/3 the amount of pages as the -1 does, and this specifically 301.489-3, the classification of SRD or short-range devices. Product family is divided into device types having its own set of performance criteria. The classification is based on the impact on persons and or goods in case the equipment does not operate. Unfortunately, I think that's the old classification. I must have missed that requirement, because they had the device types in the -3, three different types. It's no longer in the new standard. They just have short-range devices. They don't have you aren't trying to determine how it's going to affect people if you don't have that radio communication. So they've done away with that. What they've done is they've shown you what the performance criteria is for the -3. Basically class A and criterion A and criterion B, and A operates as intended during the test, and after the test it operates as intended. So you can't have a loss of function or unintentional responses. Whereas when you do B, which is going to be for transient phenomena, you may show a loss of function or no unintentional responses. However, it has to be self-recoverable, as you see in the second note of the table. Loss functions shall be self-recoverable, no degradation, things along that lines. Just kind of, again, depending upon the type of phenomena that you apply, it's going to determine how the unit has to operate. This is performance criterion from the -1 again. I don't know how they got there. This is for surges applied symmetrically for transients. This is right out of the -3. Surges applied to symmetrically operated wired network ports intended to be connected directly to the outdoor lines. The following criteria applies. If you have only one symmetrical port, loss of function is allowed, provided the function is self-recoverable or can be restored by the operation of the controls by the user in accordance with the manufacturer instructions. A software boot is not allowed, software reboot. Information stored in non-volatile memory or protected by battery backup cannot be lost either. So it's a little bit different. I mean, you can have that loss of function, and you can, it does allow the operator to use a few controls, but cannot do a complete software reboot, which is a little bit different than what we get in the -1. What happens if you have more than one symmetrical port? Well, the loss of function on the port under test is allowed, provided the function is self-recoverable, and a software boot is not allowed. But information stored on the non-volatile memory or protected by a battery backup shall not be lost. Kind of the same thing, but it doesn't really say that you can lose the other symmetrical ports if you have more than one port. It's kind of the way I read it. The one you're testing, you're allowed to have degradation, but the other one still needs to operate, or the other ones, depending upon how many there are. But then it went on to say, for all other ports, whatever kind they are, they don't have to be symmetrical for this. Basically the same thing. The equipment continue to operate as intended. The performance cannot be below a permissible performance level specified by the manufacturer. Some cases we can change that with a permissible loss of performance, depending upon what the customer can expect or what the user can expect. But this is the kind of information that it goes into this detail in the higher level. This is out of the 301-489-3 standard that speaks specifically for the other different types of testing. Transients, no change of actual mode of operation or stored data is allowed. You can't have unintended transmissions. You can't have a change in your intended transmission, things along that lines. Again, what do we expect to see from the equipment? What's reasonable? It's reasonable to think that the unit should self-recover after the transient without user intervention, but it may, in some small instances, may be a little different. They also show the performance criteria for devices that don't provide a continuous communication length, which is not addressed in the -1 at all. You still have to use the criteria described in 6.1 and 6.2, which actually is the continuous phenomena and the transient phenomena. The performance criteria is designed, actually it says the performance in 6.1 and 6.2 are not appropriate. The case the manufacturer is going to declare for inclusion in the test report his own specification for the applicable level of performance. So it may be continuous and the phenomena or the actual performance requirements are not quite correct. So they have to come up with their own. But the performance specifications should be included in the product description and the documentation. And you still have to give the same degree of immunity protection as called out in 6.1, 6.2, the continuous and the transient phenomena performance criteria. So there's going to be some similarity there, but they don't have a specific one just for that, and the manufacturer would have to come up with it. Sorry about that. So the performance criterion A applies for immunity tests with performance with phenomena continuous. Performance B is for transient, and whether the phenomena is considered transient, continuous, or otherwise is in the test procedure. And here again is the table out of the -3 that shows what your performance criterion are. Operates as intended with no loss of function. One of the things they did also put in here is when the EUT has more than one mode of operation, the unplanned transition from one mode to another is considered an unintentional response. So the EUT's got to be tested in sufficient modes to confirm that there's no such unintended response. You basically have to evaluate your device in all modes, and changing modes itself is an unintended response. So that would show the unit not compliant if that happened. This is a little interesting when I found this right in the 301-489-3 today. This is the latest standard, and as you'll notice, the radio frequency electromagnetic field test, the 9.2.2 test method, says The test shall be performed over a range of 80 megahertz to 2.7 gigahertz. Well, the standard's gone to 6 gigahertz. I honestly feel that this was a misprint, but it does say 2.7. So if you've got a short-range device, you could do this the shorter RF radiated immunity requirements and still be in compliance, I believe. But when you go back to the -1, the -1 shows you go test to 6 gigahertz. Again, anytime I'm into the standards and reading them, it seems I do seem to find these small little bits and pieces, if you will, that show differences that I wasn't expecting to see. So in the test method for the common mode is going to be subject to immunity tests for harmonized standard directives. So for example, if you've done conducted common mode for the EMC directive, for example, it may be used if this alternative modulation. Yeah, so you can use a different modulation if it's going to be more effective in determining your device is susceptible. But you have to note all of that in the test report. But that was the some extent of the special conditions that they had in the -3. It was just those two standards. It didn't say that when you do radiated emissions, for example, you use a different limit or anything like that. It's just talking about the radiated immunity and conducted immunity being slightly different than the actual -1. So now we'd like to take a little bit of a look into the actual tests themselves. Radio frequency electromagnetic fields. The -1 shows from 80 megahertz to 6 gigahertz at this point. It uses the test methodology out of the 61004-3. The requirements of the evaluation test results shall apply, and you use a 3-volt signal, which 3 volts per meter, which is measured unmodulated. Then the test signal has to be amplitude modulated 80% by a 1 kilohertz tone, or if the wanted signal is modulated at 1 kilohertz, then we use a 400 hertz tone instead. So you really have to understand the modulation of your device and what you're testing to determine, well, which one of those actually makes sense to use, which one's going to show me whether the device has any kind of immunity or a susceptibility. Test is going to be performed from 80 megahertz to 6 gigahertz with the exception of any exclusion bands from the transmitters, the receivers, or the transceiver as appropriate. And again, this is another instance where if we do use a exclusion band, we will have to document that in the test report to show what part of the spectrum was not evaluated. ESD, radio and ancillary equipment. The requirements are plus or minus 4 kV air and plus or minus 4 kV contact discharges and plus or minus 4 kV air to 8 kV air discharges. And everything else comes out of the 61004-2. The 61000-4 series is going to tell you how to do the test. It's going to tell you what the requirements are for the ESD pulse. It's going to tell you what your test setup has to be, that you have to have separation from the horizontal coupling plane by 5 millimeters, things along that lines, are all going to be pointed out in that 61000-4 series manual as opposed to the 301-489 series. Electrostatic discharges are going to be applied to all exposed surfaces of the EUT except where the user documentation specifically indicates a requirement for appropriate protective measures. There's some ESD warning in the manual that says you don't touch this particular part of the device because ESD will cause it to be interrupted. You can skip that portion of the device for the test. Moving on to fast transients, EFTs as we call them, they're going to be performed on the AC mains power port. So obviously we're not going to do it to the portable device or not likely the mobile device. The test is going to be additionally performed on any signal ports, telecom ports, control ports, even DC power ports of the radio and ancillary equipment if the cables may be longer than 3 meters. They believe that if they're going to be less than 3 meters, they will not ever be subjected to this phenomenon, and therefore they will not be tested. Common mode immunity tests are performed on the AC mains and again on any of the other ports that are longer than 3 meters in length, where we couple directly to the cabling, either through a CDN or typically through a CDN or an EM clamp, where we'll subject the unit to 3 volts RMS from 150 kilohertz to 80 megahertz, and at that point we make sure the unit is going to be compliant. 4-6 test levels again are 3 volts per meter, or 3 volts RMS. It's not per meter because we're directly coupling, and as you'll see, the modulation is the same as it is for the radiated immunity. 80% AM modulated for 1 kilohertz or 400 hertz, depending upon your modulation of your device. And we're going to go from 150 kilohertz to 80 megahertz with the exception of any exclusion band. We may have devices that receive in that area or transmit, so we can exclude the previously mentioned exclusion bands for these tests. Transient surges in the vehicle environment. If you have a vehicle device, the transients become different than the typical transients that we have in a fixed location. For example, we would not use the 61000-4-5 series to do the surges. We would use the ISO 7637-2, and that's going to give you either a 12 volt or a 24 volt DC supply, depending upon the vehicle type and where you're going to use it. And this is going to simulate more of the surges that you're going to see in a vehicle environment. The inductive kick you get from the alternator, for example, or just different things that happen in a vehicle that are not going to happen on a regular AC main, for example. And again, we use a 7637-2. It calls out the specific pulses, 1, 2AB, 3AB, and 4. This is new. It used to call out the 5, which was the surge. They called it a dump, where it was left a lot of energy, put a lot of energy in it, and it tells you how many times to apply it. 1, 2A, 2B, and 4. You do 10 times each. 3A and 3B are for 20 minutes each. Now 3A and 3B are actually EFT pulses, so you run them for 20 minutes. So you got to kind of know what your device is, because that's a lot longer than a normal EFT test. So if you're running it instead of 1 minute, you're running it 20 minutes, you really need to pay attention to those different little instances in the requirements. And it's going to be continuous phenomena or transient phenomena, depending upon which pulse you're using. Voltage dips and interrupts. You know, the AC power mains, we call these brownouts sometimes, where you aren't getting as much of the energy as you thought you were. You're going to apply it to the radio and the associated ancillary equipment. And you're going to use the 61004-11 as the test methodology. And then you're going to do the dips as required. A voltage dip to 0% for a half a cycle. And then they want you to do a voltage dip of 0% for a full cycle. A cycle being one cycle of the AC input waveform. So either 50 hertz or 60 hertz, depends on the duration. But they call it by cycle as opposed to by time. And then you drop to 70% for 25 cycles. That's a pretty good little brownout. So you're, what, about a half a second there. And then we also interrupt the voltage completely for 5 seconds. And you turn it back on, you let it come back up for a little bit, then you turn it back off to 0. You wait you turn it back on after 5 seconds, wait for 10 seconds, turn it back off. Sometimes you'll see issues with the device, especially if it's starting to reboot and you turn it back off again. That type of information, that thing is that will cause sometimes to have issues. Surges, AC mains surges and some DC surges, and on telecom ports if you have any. That's all done by the 4-5, 61004-5 series. The surge generator gives you that 1.2 by 50, 8 by 20 combination wave. And it gives you specific requirements as to whether you're going to an outdoor cable or you're using line to line or line to ground. It'll tell you the different levels that you need to test to. Test level for the telecom ports intended to be connected to indoor cables longer than 10 meters. See, if you're a telecom cable, you have to be longer than 10 meters to have applicability to the 4-5. And so you just do a half a volt line to ground to make your 500 volts, actually half a K. The mains, you do line to line, line to ground, 1 volt up to 1 kV line to line, up to 2 kV line to ground. The one thing about these tests that you do need to remember is that you need to show compliance to all the lower levels as well. So by the time you get done surging everything on an AC port, because you're surging all the different angles of the input waveform, and you're surging positive and negative, 5 at each point, you end up doing hundreds of surges on the device by the time you're done. So that's kind of a quick run through the immunity tests and some of the few differences I've seen for the upcoming RED. We've got to determine the standard. The standard, again, the determination is a little bit more difficult because we do not have harmonized standards. However, you can go to the ETSI website, www.etsi.org, and look for these 489 series standards. And if you find that they are written and they're said to be the final draft, they're pretty close to being a stable enough standard to test to. It's interesting because with the radio equipment directive, now the notified bodies are giving a type approval certificate. It's not a notified body opinion any longer. And the radio equipment directive seems to indicate that the type approval certificate is specifically for Article 3.2, which is the efficient use of spectrum. So you don't really need to have or use a harmonized standard for the other article, the article 3.1a, 3.1b, which are low voltage directive and EMC. Don't necessarily have to have a harmonized standard, but you need to address that information somehow, and most people are doing that in their risk analysis, which is a requirement because the RED is a risk-based directive. You see that you need to have a risk analysis, and that in turn has to explain why you've used what you've used. We've also looked a little bit at how the standards work together, the -1 being the base standard, and all the other devices, the -3, the -17, etc., how they can change the requirements slightly for the -1 for specific radio type. We spoke of performance criteria, and we spoke of test methodologies and test methods. Really difficult to get a lot of information in a 1-hour presentation, but again, if you have any questions, please feel free to contact either myself or anyone at the Academy, and they'll get the questions to me, and we can move forward from there.
Well, Steve, we did receive a few questions. Let me try to take on some of these for you. We got a couple of minutes left over. In your applicability table, it mentioned surges are not applicable for mobile devices, and then in the ISO 7637 section, you did show applicability. Can you clarify?
Well, let me look at that real quick. It appears that when I copied over the table, I must have missed the transients and surges to DC power input ports. That table in the 301-489-1 does show that transients and surges are applicable to mobile equipment.
Very good.
Although it does say that they're not applicable to base or fixed equipment or portable.
Okay. Good. Thank you. I got another one here. We're using test software for 61004-11 that mentions open and short test cases for the zero voltage dips. Are tests at both of these required?
Very good question. So the device has both open and short for the zero degree crossing. Was that the question?
Well, it says it shows open and short. The question reads, measuring open and short cases for the zero voltage dip. Are both of these tests required? So maybe the person asking can more detail?
I believe I saw that came in. I think it was Dan.
Mm-hmm. I can enable his microphone if he'd like to speak. He can just
open and short, 0 volts. I'm not familiar with that terminology for that specific device, I don't think.
Why don't we take that as an action and you get back with him after a follow-up?
That would be, I think that's what I need to do, because I'm trying to think at 0 volts, if I've got an open or a short, if I have no volts, how does that matter?
Could you, the person asking the question, send Steve K at WLL an email with the question and let him reply? Okay, we'll go on with others at this point. If multiple wireless modules are in the same device, can you combine the immunity testing into one test program?
That's a good question. I mean, your requirements are that you evaluate the device in all modes, and all the different wireless devices would be different modes, for example. Now, if you were able to enable all of your wireless devices at one time, it's very likely that you could do one set of tests. But it gets a little difficult when you're trying to do, for example, Wi-Fi and Bluetooth together. They kind of sometimes jump on top of each other. So therefore, it's not impossible. It can be tricky. But again, if you can get everything running and look and evaluate everything at the same time, it can all be done as one test.
Okay, good. What conducted immunity tests are required on battery-powered devices that is not operating while recharging of the battery?
Well, that's kind of an interesting question in and of itself as well, because if the device is not operating, is it truly a radio device? If it's just the only function that's happening is the recharging, then the 301-489 series would not require you to test that. However, because that recharger itself is a digital device, probably has switching supplies and things and control, that should fall under the EMC directive, in my opinion. So, yeah, you would still need to do something for that, but it wouldn't be limited to the radio equipment directive. Does that make any sense at all?
It does to me. I hope the question, the person who asked it made sense. Well, there's a follow-up here on that. If charge mode testing is required, is a device performance test required after charge mode testing?
Well, if you're testing it in the charge mode, that mode itself would be, again, this would be my opinion, but the way I would look at it would be, is the unit charging or not? The actual transmitter performance would not be an indicator of the device charging, if you will. So you just have to see that the unit's still charging, because we have to evaluate all the modes, and we have to think about what mode we're testing when we actually go and look at the tests.
Steve, I want to interpret my view on that question too, to ask you a follow-up on it. If the charge mode is done for transients and things of that nature because of the EMC requirement, as a post-test event, would the radio performance, operating correctly be required? I think that's what he may have went for. Can you comment?
Well, it's kind of a gray area because, again, we're looking at the charging, but obviously when we're charging a radio device and we get a surge on the power line with the radio is just charging and the radio itself becomes damaged, that would be something that the user should not expect to happen. So it would have to be evaluated, but possible. But again, I mean, if it's a mobile device, there really isn't in the table in 489. It doesn't show that surges are applicable. So it's kind of a hybrid, if you will, and I think that would have to be evaluated on a case-by-case basis. But I would have to say that if anytime you're using a charger for any device, radio or not, if it damages the unit you're charging by doing the testing, then that would be a fail.
Okay. We'll go on to another here. I've noticed that the specific standard calls for radiated immunity up to 2.7, but you indicated -1 test to 6. Would 6 be required no matter what the specific said?
Well, the 489-1 states that unless the higher level standard makes a change, it believes that it indicates that the 489-1 carries precedence. So that being said, the 489-3 series would in turn override the requirements in 489-1, right? So if the 489-3, and I'm looking at it right now again. The final draft of 489-3 version 2.1.1, which was published in March of 2017, says in that first table, you test over the range of 80 megahertz to 2.7 gigahertz. So if you do that testing that way, you're in compliance with the standard. I think it's a misprint, but it is what the standard says. Now I could see, for example, if you were in the 303, if you were in had a device that was transmitting less than 30 megahertz, certainly wouldn't be a big issue. But this standard for short-range devices covers everything, even some of the 2.4 gigahertz stuff. So I'd have to say my experience is I believe everything needs to go to 6 gigahertz, but black and white in the standard for the -3s tells me a little different. So I guess you have to make sure you specifically read each standard and look at that very closely and to make that determination.
Oh, very good. That was an excellent question that came in. I don't see any more questions at this point. I would like to take a moment, Steve, and go to some what's coming up mode here, if you don't mind, and we'll see if any other questions arrive while I do that thing. Okay. All I got to do is get control here. We do have a lot of things, upcoming training at our website, so you need to check that frequently. The announcement for environmental things, 810 basis, will be coming out next week. I've got replies from all of my speakers, and so we'll be announcing the content of the environmental testing, and it goes beyond just 810, even though it's just the basis. Steve, you mentioned the risk analysis in your presentation, and we do have that coming up next week as our wireless exchange, wireless risk management thing. So if you have not dealt with risk management, it might be a good topic to get an introduction and how to handle those things. Our product electrical safety series completed yesterday, but the recordings are available. That was a 6-part series on dealing with electrical safety, and since the RED requires low voltage requirement no matter what voltage, it might be an interesting thing for people to go back and see about that. We do have coming up in first week of June a 3-day PCB and integration design course with Robert Hansen, S-O-N, I didn't spell his name completely, at our Gaithersburg facility. This 3-day event will integrate PCB design and how to integrate that into your product to maintain EMC compliance. A very interesting topic, so it's time to get registered. It is a resident course, so planning. We had a battery technology series early in the year, and it was so well received it got requested, so we're doing it again in September. This is an excellent thing dealing with battery, what types of batteries, how to manifest them, wireless work with batteries and monitoring remotely, and all of those topics are covered by the Battery University CEO, Isidore Buchanan. So if you have any batteries or plan to design batteries, it's an excellent piece. Even users get a lot out of this because how to maintain and care for their batteries is one of the topics. So consider that in your future. The MCS and SIPI 2017 Symposium is the week of August 7th in Washington, D.C. As I mentioned during the introduction, I know Steve is on a tutorial for some wireless things for that. And there's many topics dealing with the Internet of Things and the associated wireless technology that supports it. It's the theme of this year's symposium. So if you have the opportunity and need to come to the Washington area, please do that. Also, if you're unable to get travel funding, then you might want to consider the digital symposium, where many of the speakers are allowing a live transmission of the events. I know that Steve, the tutorial, agreed to have it wirelessly transmitted during digital, so I look forward to that. Going to check questions. I do not see any more arriving. Remember, during the training, if you have something specific, let us know. We'll try to get the right people to do this and do presentations either through the Academy webinar package or live events at your facility or ours. We do this continuous kind of thing. So let us know. Remember, the recordings of this event will come out. One more look for questions. I don't see them. So let us know what you'd like to have. Our next webinar is next week, I believe, at this time, May 31st at the 11 a.m., dealing with the risk management. Several things are there, so check our websites. And I know the website's going to be updated very shortly with new announcements because I've got speaker agreements in place finally. This concludes our webinar. On behalf of Washington Labs, myself, and the entire Academy team, I'd like to thank you for attending. We'll now close the meeting. One more look at questions. Thank you, Steve, for such a great presentation, a lot of information. So with that, I will go ahead and close the event.